Hi, so for today we're going to talk about complex number operations. This is a part of the Advanced Engineering Mathematics lecture. So for today's video, we're going to solve some complex number involving its operation. So let's get started. So a quick review what a complex number is actually it's composed of a real part and an imaginary part. And we know that sometimes or most of the time, the notation for the imaginary to represent the imaginary number is represented by I. And I is actually equal to square root of -1. So for today, we're going to solve some problems involving complex number. So for number one, if z sub 1, that means we have a complex number because complex number usually it is represented by z. So we have z sub 1 is equals to -1 plus I. Now this is the real part and we have the imaginary part. And z sub 2 is equals to 2 minus 3 sub I. Then we are going to find 2 z sub 1 plus 4 z sub 2. So what are we going to do here for our solution for this? We are going to actually apply the basic operations such as the distributive, the associative, okay, the properties, okay, in basic algebra. So what are we going to do? 2 z sub 1, that means twice the z sub 1, which is -1 plus I. Then we have plus 4 times the z sub 2, which is 2 minus 3I. So simply evaluate. 2 times -1 is -2. 2 times I, that's plus 2I. And then we have plus 4 times 2 is 8. 4 times -3I is -12. So we can simplify some of the values in real part and in the imaginary part. So if we are going to simplify, so we can simplify -2 plus 8, that is obviously 6. And then we have plus 2i, positive 2i minus 12i, that is -10i. So this is our answer for our first item. So for letter B, we shall be finding uh, z sub 1 multiplied by z sub 2. Okay, so if we do this, of course, we have z sub 1, it is -1 plus I, then multiplied by z sub 2, which is 2 minus 3I. So we will apply FOIL here. So first, -1 times 2, that's -2. Outer, we have -1 times -3I, that's plus 3I. In the inner, we have plus 2I. And the last, positive I minus multiplied by -3I, that's -3I squared. And if we encounter I squared, okay, take note that because I is equal to square root of -1, I squared therefore is equals to -1. So we can simply reduce this into 3 times -1. So we have -2 plus 3i plus 2i minus 3 times -1 because I squared again is equal to -1. Continuing our operation or our solution, -2. Okay, and then we can simplify this as positive 3 because we have -3 times -1, that becomes positive 3. So 3 minus 2 would be 1. Then we can add these two. Then we have plus 5i. So that's how simple it is on operations of complex numbers. So let's try another one for letter C. For our problem here, we have 3z sub 1 minus 2z sub 2. So how are we going to do this? 3 times -1 plus I minus 2 times z sub 2, but that's 2 minus 3i. Again, we should distribute this. We have -3 plus 3i. Then we have, don't forget to distribute also the minus sign due to the subtraction. So we have -4, then we have plus 6i. So we can simplify this. -3 minus 4, that's -7. We have 3i plus 6i, that's 9i. So this is our result, the final answer. Okay, for letter D, we shall try to find z sub 1, okay, minus 4 times z sub 2. So we have -1 plus I minus 4 times a sub 2, that's 2 minus 3i. Then we have negative 1 plus I, that's negative 8. Distribute this negative 4, and then we have plus 12i. Simplifying, we have negative 1 minus 8, that's negative 9. And then we have I plus 12i, that's 13, positive I. Positive 13i. Okay? Let me just rewrite the plus sign here. Oops. That is our answer. Okay? So for number 2, okay, that's number 1 only. So how do we find the operation of this complex number? So we have 1 minus 2i over 3 minus I plus 1 minus I over 1 plus I. So what are we going to do here is, we, as much as possible, we need to eliminate the denominator containing I. So in other words, when solving complex problems or complex numbers, involving complex numbers, we are going to actually, as much as possible, eliminate the I on the denominator. So what are we going to do here is, first, I'm going to multiply each term by the conjugate of each of the denominator. So what are we going to do again? That is 1 minus 2i, 3 minus I. Now, I'm going to multiply this, okay, by the conjugate of the denominator. The conjugate of the denominator, we're going to change the sign, okay, of whatever is the imaginary part. So that's 3 minus I. I'm going to have, of course, copy the real part. It will become 3 plus I over 3 plus I. Notice that this is still equal to 1. Okay, we multiply it to this. So still, we are not violating any of the rules here because we simply multiply it by 1. But in this way, we are going to eliminate the I in the denominator because of I squared, and that is equal to negative 1. Of course, if I do that on the first term, I can also do that on the second term, which is 1 plus I. And then if I'm going to multiply this by the conjugate, okay, of the denominator, that's 1 minus I over 1 minus I. So again, we are going to perform our skills here in multiplying complex numbers. So what are we going to do? Denominator times denominator. So we have the denominator. Let me just rewrite this. So we have one first, that is 3. Outer, that's 1 times I, that's plus I. Inner, we have negative 2I times 3, that is negative 6I. Okay? And last, we have negative 2I squared over, of course, if we are going to really review this, 3 minus I times 3 plus I, remember that we simply multiply this, the first part, okay, first term and the last term. So that's actually having a x minus y, then we have x plus y, okay, in your algebra. So how do we get this? So we are going to have x squared minus y squared. Of course, the same as this. So we have x squared, which is the 3, then minus I squared. Then moving on to the second term, so we have 1 minus I. We have 1 minus I, both 1 minus I. So we're going to simply square this. So we can have 1 minus 2I, okay? 1 minus 2I, okay, plus I squared. If we expand this, okay? There's a shortcut there. So again, the denominator looks like this one in our algebra. So we have 1 squared, okay? 1 times 1 is 1. And then we have minus I squared. Okay? And then we're going now to simplify this. Okay? Before we perform the addition. Okay? So what will happen here is that we have, we simplify first the I. We have plus I minus 6I. That is minus 5I. and negative 2. We know that I squared is negative 1 over 9. Okay, we know that this I squared is again negative 1 plus that is 1 minus 2i. We know that that I squared is equal to negative 1 over 1 minus negative 1's, okay, negative 1, I'm so sorry, negative 1 only, because I squared is equal to negative 1. So, be careful with the sign. So, this is minus, okay, but I squared is negative 1. So, okay, we will be having a positive 1 here. So, let's try now. So, negative 2 times negative 1 will become positive 2. So, in that we have 5 minus 5i over 9 minus negative 1. That is over 10. Then we have plus 1 minus 2i. 1 minus 1, this would cancel, obviously. So, we have negative 2i here over, then 1 minus negative 1, that's 2. Okay. So, what will happen here is this would become 5 minus 5i over 10. Then we have minus, these 2's will cancel. That will become minus I. But of course, we can still factor out 1/5 here because it's common. Okay. So this can be reduced. Or we can, we can factor out 5. So we have 5. Okay, and then we have 1 minus I. Of course, on the denominator also, we can factor 5. That's times 2. 5 times 2 is 10 minus I. So these 5's will cancel. And then we have a 1 minus I over 2 minus I. That is minus I. So if we perform this, okay, we have 1 minus I minus 2I over 2. Then definitely we have 1, okay, then minus I minus 2I, negative I minus 2I, that's negative 3I over 2. And of course, we can rewrite this as 1/2 minus 3 over 2I. And this is our answer for this problem. This shall be our answer. So first, if we have a denominator that is containing I, we should first multiply it by its conjugate, okay, in order for us before we solve the certain operation in the complex number. Okay, so this is the answer for our problem number 2. So for our problem number 3, we have 4 plus 5i, quantity 4 plus 5i multiplied by 4 plus 7i. Okay, by foil, we have 16 first, outer, we have plus 28i, inner, 5i times 4, that's plus 20i. Then we have 5i times 7i, that's plus 35i squared. Remember again that I squared is equal to negative 1. Okay, so we have 16 minus 35 due to negative 1. This 35 is multiplied by negative 1. So that becomes negative 19. Okay, and then plus 28i plus 20i, that's plus 48i. Oops, let me just rewrite. That's plus 48i. So this is our answer for this problem. It's easy, right? So for number 4, we have 2 square root of 2. Then we have plus I multiplied by, that's minus I multiplied by 1 plus square root of 2I. Okay, so this is very simple. 2 square root of 2 plus I. Distribute the negative sign. Okay, and distribute this. Multiply it by this term. So we have negative I. Okay, minus square root of 2I squared. Okay, and we know that if we continue this, that negative I squared is simply equal to negative 1. So this term becomes negative 1 times negative square root of 2. That becomes positive. So we have positive square root of 2. Plus I minus I will cancel, so this is 0. Then we have 2 square root of 2 plus square root of 2, and that is 3 square root of 2. So this is our answer. Okay, for number 5, we have 1 minus I raised to 3. So this is also equal to 1 minus I squared times 1 minus I. Okay, so what will happen is that we're going to square this. We have 1, okay, minus 2I, okay, plus I squared, and that is multiplied by 1 minus I. So we can multiply this 1 minus I, distribute this. So what will happen here? First thing to do, first thing to do is to let this I squared be equal to negative 1. So we have 1 minus 2I plus I squared, that's plus negative 1, of course. So as you can see here, 1 plus negative 1, okay? 1 minus 1, or 1 minus 1 because of the negative sign here, the 1's will cancel. So we have negative 2I multiplied by 1 minus I. So we have negative 2I times 1, negative 2I. Okay, and then negative 2I times negative I, that is plus 2, 2I squared. Okay. And our answer, I squared again, is equal to negative 1. So we have negative 2 minus 2I. So this should be our answer for this problem. Okay? So for number 6, we have 1 minus I over I minus 1 plus I over 1 minus I. So before we perform the subtraction or subtraction operation, we must again multiply each term by its conjugate. So we have 1 minus I over I. The conjugate of I, okay, is simply what? A negative I over negative I, and that is minus 1 plus I over 1 minus I. Going to multiply this by its conjugate, that is 1 plus I over 1 plus I. Okay, so what will happen here? We have numerator times numerator, that is negative I, okay, that's plus I squared, over, we have negative I squared here on the denominator. Okay, then we have minus, that is, we are going to multiply this, that's 1 plus 2I, okay, plus I squared, okay, all over 1. This is again the difference, okay, so 1 times 1, that's 1, I, negative I times negative, positive I, that's negative I squared, excuse me. So that's negative I squared. So what will happen here? Again, replace negative I squared by negative 1 over negative of negative 1, okay, minus, we have 1 plus 2I plus negative of 1, negative 1. Then we have 1 minus negative multiplied by negative 1. So we can see here that this is negative 1 minus I over 1, or simply negative 1 minus I. Then we have 1. So this 1 will cancel because 1 plus negative 1. So this would become 1 minus 1. So this would be cancelled. So we have 2I here over 1 minus negative 1. That's 2. As you can see, these 2 would cancel. So we have negative 1 minus I minus I. Okay, that is simply negative 1 minus 2I. So this should be our final answer. So let's go now for number 7, if I'm not mistaken. So we have 1 plus I squared over I. So evaluate that. That's very easy. So what are we going to do? is to, again, simplify first the numerator. Okay, so what are we going to do? We have 1 plus 2i plus I squared over I. So as you can see, for this problem, there's no need for you to actually multiply the this term into its conjugate. You will see why. Because if you later on, they call this simplify the numerator, you see that the I will cancel. So we have 1 plus 2i. Then we have plus I squared, that's plus negative 1 over I. So this means 1 minus 1. So we have this 1 would cancel. Okay. Then we have the remaining 2i over I. The I will cancel. Okay. The I term. Okay, the imaginary. So we have an answer of 2. Equivalent to 2. Okay. For number 8, we have quantity squared of 2 minus I quantity 1 minus square root of 2i. So pretty similar problem we had a while ago. So we can distribute the I together with its sign for this term. So we have negative I, then we have plus a square root of 2i squared. So what will happen here? Negative I minus I. We have square root of 2 negative I minus I. We have negative 2i. And for our I squared, that is actually equal to negative 1. So what will happen? We have square root of 2 minus 2i. Negative 1 times square root of 2, positive square root of that becomes minus square root of 2. So these 2 will cancel. And then we have an answer of negative 2i. Okay? So for number 9, we have 1 minus 2i over, we have 3 minus 4i. That is plus 2 minus I over 5i. So again, we are going to multiply each term by its conjugate. By the conjugate of the denominator. So this must be 3 plus 4i over 3 plus 4i. And then we have the plus. We have 2 minus I over 5i. The conjugate of that is negative 5i. We have negative 5i here. Then we have negative 5i here. Then what are you going to do? Simply perform. Okay? So we have first 1 times 3. We have 3. Outer we have plus 4i. We have inner negative 2i times 3. That's negative 6i. We have last negative 2i plus 4i. That's negative 8i squared. Over, since this is the product of the difference. Okay? So we have 9 minus 16 by I squared plus, of course, this. So we have negative 10i and then we have plus 5i squared over the negative 25i squared. So upon simplifying, by substituting I squared is equals to negative 1. So we have this negative 1 over 9 minus 16. We have negative 1. Okay. That is plus 5i or 5 times negative 1 minus 10i over negative 25 times negative 1. Okay, so let's evaluate. So negative 8 times negative 1, that becomes 8. Okay, plus 3, that's 11. Okay, then we have 4i minus 6i, that's negative 2i. Okay, then over 9 minus 16 times negative 1, so this becomes plus 16. So 9 plus 16 is over 25. Then we have plus, okay, then we have negative 5 minus 10i all over 25. Okay, so since they have the same denominator, we can rewrite this as 11 minus 2i minus 5 minus 10i all over 25. And simplify, we have 11 minus 5, that is 6. Okay, negative 2i minus 10i, that's negative 12i. And then we have over 25. And that is our answer for this problem. Okay, down to our last problem. For problem number 10, we're going to solve I raised to 2004 plus I raised to 1997, okay, plus I raised to 1957 or 1957. So how do we evaluate this? So if we encounter these complex numbers raised to such a huge, okay, exponent, so you're going to recall that I is equal to square root of negative 1. We have I squared is equal to negative 1. I cubed, how do we evaluate that? That's equivalent to I squared multiplied by I. But I squared is equal to negative 1. Then we have times I. Okay? And that is equivalent to negative I. But I raised to 4, okay, remember that it could be split up into I squared times I squared. And I squared is simply equal to negative 1. That's times negative 1. That's equal to 1. So if we see things such as this, okay, so we are going to do what we did here in IQ. So if the exponent is divisible by 4, then automatic that is equivalent to 1. Without remainder, if we divide 2004 by 4 without remainder, automatic that is actually equal to 1. So 2004, I raised to 2004, if we are going to divide this by 4, I'm pretty sure that this is divisible by 4, that is equivalent to 1. So this term is only equivalent to 1. How about 1997? Okay, I don't know. I really think that 1997, I raised to 1997 is not divisible by 4. So I have to find the nearest, okay, number divisible by 4. So I raised to 1997 or 1997 is equal to I raised to 1996 times I. And I know that 1996 is divisible by 4, so I can replace it simply by 1 and multiplied by I. So this is simply equal to I. Okay, this second term is equal to I. How about 1957 or 1957? Okay, that is not again divisible by 4, but the nearest number that to which it is divisible by 4 is 19 or 1956. Okay, multiplied by I. Okay, that's equal to 1957. So I know that this is divisible by 4. Okay, you can try. Okay, and then that is equal to 1, and that is multiplied by I, and that is 1 times I is equals to I. So simply, I'm going to replace this whole question by 1 plus I plus I. So simply, our answer should be 1 plus 2I. And that's it for today, guys. So I hope you learned something about complex number, the operations of complex number. And for the next video, we'll be tackling about the modulus of the complex number. So thank you so much for listening. I hope you did learn something for this video about the complex or basic operation of complex number. If you are new to my channel, please don't forget to subscribe and leave this video a thumbs up. So thank you so much for listening. Again, this is Engineer Abat. Abat, God bless you.